Research is about the preparation of gold nanoparticle and coating onto titanium particle for IVD testing. IVD testing or in vitro diagnostic test are medical tests conducted in a controlled environment outside the living organism. And IVD test is to detect the nutrients, hormone, disease, therapeutic drugs, and environment contaminants. This is the structure of an IVD test device. They contain black membranes. One side connect with conjugate part, and the end side connect with adsorbent part. In the membrane, there are a test line and a control line to show the results. Let's see about the mechanism of IVD testing. There are IVD test device with a conjugate part contain the dry detector. In this case, we use gold nanoparticle conjugate with antibody. And when we add the sample with antigen will mixing with the detector, and some antigen conjugate with antibody. They flow through the membrane and added adsorbent pad. In test line, the antigen conjugate with the detector will be held, and only detector held in control line. Based on the color change in test line and control line, we will have the results for IVD test. In this case, all of the test line and control line change the color into red. This means that they are positive or you have antigen in sample. If only control line change color, we have negative results. It means that no antigen in the sample. And in the circumstance, no line change color or only test line change color, we have no answer, or we need more tests to get the results. There are some material used for IVD testing. For example, for nucleic detection, we use enzyme, quantum dot, ribosome, and gold. Gold nanoparticles are choice material because they are non-poisonous and they have a large surface area, easy conjugation with biomaterial. They are high sensitivity with biomaterial, and they have high absorption and scattering coefficient. This means that they show the red color in the UV region. In the side comparison between the gold nanoparticle and another substance, we found that gold nanoparticle had the same size with macromolecular. For example, the nucleotide oligosaccharide, and it means that gold can make the mimic material for the macromolecular, and to determine and inhibit and treat the cancer or tumor cell in incubation. Recently, there are some papers report about the application of gold nanoparticle in medical. In this case, they can use to detect the mismatched DNA for bioimaging and phototherapy of cancer cell, or recognition and anti-adhesive therapy of tumor cell. Gold nanoparticle usually synthesized by a reduction. Gold precursor reduced by reducing agent to make the gold nanoparticle. Reducing agent usually use ascorbic acid, sodium borohydrate, alcohol, or trisodium citrate. They are the half reaction of reduction gold to make gold nanoparticle. In this case, we use gold chloro complexes for gold precursors and trisodium citrate for reducing agent. Besides the application in medical, gold nanoparticle has high application in catalyst because they have high activity and selectivity, especially for the cover over the support material. For example, titanium, zirconia, or iron oxide. There are some ways to prepare the gold nanoparticle cover titanium. We can prepare by implantation, polymer microcapsule, or deposition and precipitation, and deposition in organic solvent. All other methods are complicated synthesis, and some need the purification processes after preparation. Because their gold nanoparticle cover the titanium, and gold has the selectivity and easy conjugate with the biomolecular, so we predict that gold cover titanium can be used for IVD testing. This is objective of our work. We prepare gold nanoparticle in focus of 20 and 40 nanometer and deposit gold onto titanium particle by the oscillation and reduction reaction in aqueous solution. Let's see about our experiment. We prepare gold nanoparticle by reduction reaction of trisodium citrate for gold chloroacid. In this case, we kept the temperature 70 degrees Celsius and stir through the experiment. We have two ways to prepare gold nanoparticle. In this way, we use 200 milliliter gold chloroacid and 20 milliliter of trisodium citrate 1% by reducing agent to make 20 nanometer gold nanoparticle. And 20 nanometer gold nanoparticle be the stock solution to prepare 40 nanometer gold nanoparticle by this procedure. I add trisodium citrate and then add more gold chloroacid. By another way, we can prepare gold inside about 20 or 40 nanometer by change the pH of solution. The condition in temperature and reducing agents is the same. And pH will adjust by sodium hydroxide 0.1 mole. We are also coating gold nanoparticle over the titanium particle by this procedure in two conditions, pH 3.4 and pH 7. pH 3.4 is pH of gold chloroacid by itself, and at 7 we add sodium hydroxide 0.1. We add titanium, we change amount of titanium for 3% or 6% of gold loading by weight for each condition. And we use 1.5 milliliter of trisodium citrate like the reducing agent. After 2 hours, the particle will filtrate, wash and dry to get the gold covered titanium particle. Let's see about the results for gold preparation. This is one way to prepare gold nanoparticle. This we characterize by TEM and ERS to know about the particle size and polydispersity. In this case, we get 21 nanometer of gold nanoparticle with polydispersity is 0.17879. We use this solution to prepare the 40 nanometer of gold nanoparticle, and it is the results. We got the particle size in 39 nanometer and very low polydispersity, 0.0997. It is ERS analysis for the gold nanoparticle. In this case, we suppose that after we prepare the 40 nanometer of gold nanoparticle and add the citrate will act like a stabilizing agent over the gold particle. And then, when we add more the gold chloride acid will be reduced in the surface and particle growth to make the bigger particle. In another way, based on the change of pH, we also get the gold nanoparticle in 40 and 20 nanometer. At pH of 3.4, we get the gold nanoparticle in 19.6 nanometer with polydispersity is about 0.3. And at higher pH is 7, we get the gold nanoparticle in 37.7 nanometer and polydispersity is about 0.1646. We also characterize by UV vis and all of the staples, so the peak near the 520 nanometer. It is 521 and 523. Let's see about the existence of ionic gold complexes in aqueous solution. In aqueous solution, when we add sodium hydroxide to increase the pH, the hydrolysis will be take place to make another kind of gold chloro acid. In this pH is 3.4. We have gold chloro complexes, and the higher we get gold chloro also hydrosol complexes. Based on this equation, we can calculate the standard potential for each oxygen reduction couple, and the decrease in standard potential is means that gold can easily reduce in the chloro complexes. And at a low pH, we have the first nucleation to make the unlimited particle with very small size. After that, the very small size nanoparticle will attach by random attachment and aggregation to make the particle. By another way, at pH is about 7, with slow nucleation, we have limit particle, and then the particle slow grows to make the final particle in bigger size. We also compare the product with the commercial product from BBI company and Geno Biotech company. In comparison of size and polydispersity, we affirm that our product can be used for IVD testing. And based on the formation of gold nanoparticle in aqueous solution, we predict that with the action of titanium, gold particle from the solution can be deposited onto the surface or grow on the surface of titanium to make the gold covered titanium. It is gold covered titanium prepared at pH 3.4 with 3% of gold loading. We characterize by high resolution TEM and locate in some location we found that gold in this case only co-precipitate with titanium and there are no gold particle in the surface of titanium. We have the same results for 6% of gold. But in the contrast, at the higher pH 7, we can see many small gold particles dispersed in the surface of titanium. The particle size is about 3 nanometer. And when we increase the amount of gold, we also get the gold high dispersed in the surface of titanium with the particle size is about 4 nanometer. The difference in the results was caused by the difference in interaction between gold complexes and titanium. At lower pH, gold mainly exists in gold-chloro complexes, and they have weak electrostatic bonding with titanium. But increase the pH, some of the chloro be instead by the hydrosol, and the square planar structure be distorted. The distorted square planar structure of gold complexes will lead the stronger affinity between the gold chlorohydrosol complex with titanium, and they can make some chemical bonding between the gold complexes and titanium, and then gold will reduce and grow in the surface of titanium. After all, let's summarize our work. We prepared gold nanoparticle in focus of 90 and 40 nanometer and coating over the surface of titanium particle. They characterize the form of particle by ERS, UV-vis TEM, and high resolution TEM. The 40 nanometer of gold nanoparticle can be prepared by two ways. Using 20 nanometer lysis or change the pH of solution. We synthesize gold-covered titanium with high dispersions of 3 nanometer gold nanoparticle on the surface of titanium, and gold nanoparticle deposits onto titanium due to the specific affinity of some kind of chemical bonding between the gold hydrosol chloro complexes and titanium particle. And for the near future, we are going to study about the application of gold nanoparticle and gold-covered titanium, not only in IVD testing, but also in catalytic application. Thank you for your attention.